Water is a fundamental aspect of our life. It is home to an estimated 1 million aquatic species, the playgrounds of animals and humans alike, and a natural marvel of beauty. And its cleanliness is being threatened by microplastics. What we are unaware of, though, is just how quick at infiltration that these microplastics are. How fast do you think it takes for microplastics to change our waters? A day? A week? A month? The answer? As little as 30 minutes. So how can we stop this? What is the major problem that we need to resolve? Global complacency, with the beliefs that we can wait another day being a fundamental flaw that must be exposed immediately so we can change our mindsets of waiting to actively resolving the problems in our waters. My name is Phoebe. I'm from Menai High School, and let me tell you about the short-term effects of microplastics on the filtration capabilities of an oyster. How are the two linked? Well, oysters are niche species in the marine environment. They're filter feeders that passively remove phytoplankton in the water, ensuring that the oceans remain pristine and clear. In fact, a single oyster can filter from anywhere between 30 to 50 gallons of water a day. But can man-made synthetic polymers put a stop to this natural phenomenon? This was tested by increasing the amount of microplastics an oyster was exposed to, as they were left to filter 8 milliliters of phytoplankton within a 200 milliliter aquatic environment. Samples were taken every 30 minutes and filtered before being placed between a light probe and a light source to check how much light was capable of passing through. The results? Oysters with more microplastic filter faster, after 30 minutes of doing nothing. However, what they were giving up was reproductive capabilities. The oysters were filtering faster to compensate for the 30 minutes of doing nothing, and instead giving up species continuity for immediate survivability. So how is this relevant? Well, if oysters are no longer attempting to reproduce, then a flow-on effect happens as the keystone species is removed. Waters without oysters quickly become dirty and infested with large amounts of phytoplankton, which in turn causes algal blooms. This impacts the waters as their habitability is affected, the marine ecosystem altered, and us losing a natural wonder of our world. Furthermore, under an electron microscope, microplastics were found in the tissues of the oyster in a time frame of 2 hours and 30 minutes. While we're still wondering about the long-term effects of plastic production, the short-term effects that we haven't considered is already beginning to show. So what does this mean for our environment? And what does it mean when we put it off for another day? With society unaware of the dangers that is invading our waters right now, this experiment is a call to action. Earth's natural filter feeders are being exponentially threatened. The time for ignorance is over. We need to change, here and now.